principle of operation is as follows. If we have two strips of different lengths and heat them a little, they become longer, but not by the same amount, as different metals become longer in different ways. If we weld them together, we'll now have a thicker strip which, again, bends itself as an arc because each metal becomes longer differently. This double strip made up of two metallic strips is the bottom product. Now let's go back to our thermostat. In this first drawing, the iron is turned off. You can see that the thermostat contacts are not touching each other. When we turn on the temperature knob of the iron, we are actually tightening the control screw and thus moving the upper contact down until it touches the lower contact. This turns the iron on, and the resistance mounted inside the flat base begins to build. The lower contact is mounted on a bimetallic strip which, due to the heat of the resistance, begins to bend downwards. This causes the contacts to separate and the resistor stops receiving electricity, so the iron starts to cool down. When this occurs, the bimetallic strip cools and straighten again, so the contacts are once more brought together, whereupon the resistance is energized once more. The cycle repeats itself, thus maintaining the temperature we have adjusted by tightening the control screw. If you tighten the screw a little bit more, the temperature of the iron has to increase so that by adjust.
All right. So, yes, students. Good morning. So, as for this class, we will be looking at safety devices used for electricity and thermostat. That will be the first safety device that we'll be looking at. Now, in terms of thermostat, now this device normally used in electrical appliances that have to do with heat mostly. For example, kettle and of course electric iron. Now, what this regulatory device does is that it prevent the electrical iron, for example, from being continuously getting hotter and hotter. Now, once an electric iron is working properly, and then you can actually turn that, you can plug that electric iron in for an entire day, and it will not get hotter than how it's supposed to get. And that is simply because the thermostat would have been working properly. So first and foremost, what is a thermostat? Now, it is a device which automatically regulates temperature. Thermostats activates different device when their temperature reaches a particular point. So it all depends. Now, the image that you're seeing below, you have the temperature control dial. So if we're using this image to represent electric iron, so the knob that we normally turn, that would be the control dial. And definitely they are showing you the switch. Now, the arrow that you're looking at, so this arrow with the two ends, the curved one there, so definitely, as you can see, these two sections, they are separated. That simply means that they are not touching each other. Now, what actually normally take place is that once they are touching each other, that simply means that the circuit would actually close. So that simply means that the iron is actually being heated. Now, once the iron reach a particular temperature, then they will actually separate, until the iron get cooler. So once the temperature of the iron reach, let's say for example 110 degrees Celsius, then basically what will happen is that the circuit will break. So once it reach 110 degrees Celsius, for example, the circuit will actually break, and once the circuit break, then no more electricity is reaching that section or that part of the iron that is responsible for heating it up. So it reach 110 degrees Celsius, for example, it will stay there for a while, and then once the circuit is broken, then definitely after a while the temperature now gonna get lower and lower. So that simply means that the iron will get colder. But the fact that you turn on the iron mean that once it reach, for example, 90 degrees Celsius, then the circuit gonna close back, and then the iron gonna heat up to that 110 degrees. So it is like a cycle. So 110 degrees, for example, will be the maximum, and 90 will be the minimum, where it will actually reconnect once it reaches the 90. Now there is now what made the connection is what is known as a metallic strip. So the bimetallic strip. This strip is made of two strips of different metals. So two different materials will make this strip. You have brass and you have iron. And in the diagram you're actually seeing it there. The two strips of metals normally riveted together, so that simply means that they're actually joined together. So remember that it would be two different types of metal, brass, and then definitely you'd have iron. Done before heating, so that's it. That is before you turn on the iron. They will be straight. When heat is applied, both metals expand, so they're gonna expand in terms of their length, and how they expand, they will actually expand in a curve. So brass expand more. So the brown one at the top there, which is the brass, it will expand more, and as you can see, it is actually curving. So rather than being straight, that is before it is heated, and that simply means that it is whenever it is cold. Once heat is applied, then it will actually move away. So the fact that it actually curve like this simply means that it will disconnect from the electricity, and once it disconnect from it, then definitely it will not get hotter than that 110 degrees Celsius, because the fact that it move away from what it would have connected to mean that the circuit would actually break. So when expand, the strip will curve with the brass on the outside. When the strip cools, the metal will go back to their original length. So once they go back to their original length, then definitely they will actually close back the circuit. And once they close or join back the circuit, then definitely that temperature will increase. And as the temperature getting hotter and hotter, then it actually bend or move away, hence separating or breaking the circuit, so that no more electricity reaches the iron once it reach a particular degree in terms of temperature. Alright, so here is the thermostat in the electrical iron now. So the control knob at the top there. So the part that is labeled as the control knob, that is what you normally turn. So once you turn it, it will actually force down this piece that is labeled as current. So you're seeing current and you're seeing in. So current in. So once you turn on the knob and spin it, what it does, it actually squeeze this section that is labeled as the current in. So that means that the current is coming in, and then you are seeing contact. So as you can see, it is now touching the brass section there. So once the current in touch or come in contact with the brass section, then the iron now start to get hotter in terms of temperature because the circuit is now closed. Now, looking at the brass and the iron, which would clamp to each other or rivet to each other, because coming from the previous slide, which is this one, you'll realize that the brass is on top and the iron is at the bottom section. So as it get hotter in terms of temperature, then definitely it gonna actually bend away in that downward direction. And once it bend away in that downward direction, then definitely it now not going to contact with the current in that you're seeing at the top there. Because remember that it is bending or curving away, And once it bend and curve away from that current in section, then the circuit will actually break, which simply mean that no more electricity will be allowed to go into the iron until it actually straighten back, and it will only straighten back when the temperature reduce or the temperature get cooler. So they are saying that the thermostat is used to keep the iron at a particular temperature. When the strip is straight, it forms part of an electrical circuit. So like for example, now it is actually straight. Hence it will actually be forming part of an electrical circuit. So that simply means that it is allowing current or electricity to go through to that metal plate and the iron that you will actually put on the clothes that where the heat will produce. Current will now flows through the circuit. Iron will now warms up. So once you have this contact that where you have the current in contacting with the brass, that means that the circuit is now closed. And once the circuit is now closed, then that simply means that heat now gonna produce. Now in electricity, when we join a piece of live electric cable or electric cord to one next piece of electric cable that was not live, that means that it don't have any electricity. Then once you join them, then that is when we normally say that the circuit is closed. So imagine you have two pieces of electrical iron, uh, two pieces of electrical cables, I should say. In a right hand, the piece of electrical cable or the electrical cord in the right hand, that one is live. And the piece in the left one, it is not live. That means that no current is in it. Once you touch those two pieces of cables and you actually join them together, then and there you actually close the circuit. So that's what we mean whenever we say we close the circuit in electricity. Meaning that you join a piece of cable where it is live, meaning that there is electricity in it. You actually join it or attach it to a piece of cable that there is no electricity. Once you join the live one to the one that you would say that is dead, then definitely you close the circuit. Because once you join the two of them, then current or electricity will be able to move from the live one into the one that did not have any electricity. So when the iron gets hotter than the required temperature, the strip will bend away from the contact, and that's the example they are showing down the bottom where they said where you see before eating and after eating. So before eating, of course, a metallic strip that is comprised of the brass and iron, it would be straight horizontally right across. But once it start to heat up and it reach a particular temperature, then it actually gonna bend away. So the fact that it is bending away from the contact section there mean that the circuit will break. And definitely once the circuit is break, then no more electricity will be allowed to go into the iron. Hence the iron will not get hotter than how it was designed by the manufacturer to get hot in terms of temperature. As the bimetallic strip cools, it straighten. So once it get cooler after the circuit is being broken, then definitely it's gonna actually straighten or go back to its original length in terms of its position, in terms of it being straightened, forming the circuit again. So once it is straightened, then definitely the circuit gonna form again. Current will flow and heater turns on again. So that simply means that the heat on the face of the iron will now gonna increase to that desired temperature that the manufacturer would have designed it to be. Screwing the control knob in and out will regulate the temperature at which the heater switch on. So it all depends. So let's say for example you put it at 5 versus somebody who put it at 1. When you put it at 5, that simply means that the iron it will actually stay hotter for a longer period of time. So it is not that you actually increase the temperature. It's just that you allow it to stay at that temperature for a longer period of time, which simply means that the higher you turn the knob is the less time the brass or the piece of strip will actually stay bent for, meaning that the longer they stay bent for is the hotter is the cooler it will actually get. You actually want it to get straighter if you want to increase or keep the temperature of that iron face for a longer period of time. Alright, in gas, let's say for example the cylinder also can use thermostat in motor vehicle. There's also thermostat that is used in the engine. That simply means that once the engine reaches a certain temperature, then the thermostat will actually release some cool water into the engine. So thermostat is what control the movement of water in engine. Like also, gas thermostat normally regulate the temperature in a gas oven. So let's say for example you're baking, you're using the oven. Now the oven try to maintain a certain amount of temperature, meaning that the gas regulator will actually only send in some amount of gas whenever it realizes that the temperature is below its normal or what it's supposed to be inside the oven. So gas thermostat has a rod made of invar. The invar expands slightly when heated. So once it is heated, once it is applied, then then it will definitely um, expand and expand in terms of length. So the brown section that you're looking on the diagram there, that is the rod. So once it is applied, it's going to actually expand, and when it expands, it actually will close the gap. So that simply means that no gas will be allowed. So here we have the gas supply. So gas supply, the red arrow at the top there. That is the gas supply. And so we have the bypass there. We have our next bypass down there. Down the bottom here we also have bypass. So looking at it, so the gas supply come there, go right there, and it actually move through the spaces there. So move through that spaces, and down the bottom there it is saying gas to open burners. So here we have the valve there. So this is the space, one valve on this side, and you have a next valve on that side here, and of course you have a spring. So when heated, the rod will actually expand slightly. So as the oven's temperature increase, the brass tube expand. So now they are saying that Once it expands, it will move to the left. The valve is then pulled closer. So once it pulled closer, then it will actually close off. So right there, that space that you're seeing, and at the top there, that space. So once the valve expand, it's gonna actually close that gap. And once the gap is closed, then definitely no gas will be allowed to actually go into the oven once the oven reach a particular temperature. Because if the oven just continues to getting hotter and hotter in terms of temperature, then definitely it will cause an explosion, because the temperature not steadying at, let's say for example, 120 degrees Celsius. Because if the oven built to maximize or reach maximum of 120 degrees Celsius, then what if the thermostat is not working, then it gonna go over that 120, and that is when it will actually cause an explosion, because the thermostat is not working properly. So as the brass cools, the rod move, open the valve and increase the flow of gas again. So once the oven realizes that the temperature is getting down in terms of its hotness, then it will actually open the valve and allow some more gas to flow. When this gas flow, then it will actually maintain or heat up back the oven environment. The control knob can use to alter the position of the valve and so control the steady temperature of the oven. So the valve which control the amount of gas that enter it eventually is what will control the temperature, because the more gas enter it, the more the temperature will be. So in order to regulate or prevent it from just getting hotter and hotter, then there is that valve that is regulating how much gas that is entering the oven. The fact that we're on safety in terms of electricity, surge protector. So surge protector is also another safety device, and a safety device normally used to protect electrical um, appliances from a sudden electricity overload. So let's say for example the electricity went, and then the electricity would actually come back. Now sometimes when the electricity come back, they normally say that the current is stronger than normal, and that is true. Why it is stronger than normal is because once as the current come back, then all of the customers will not start to use the electrical appliances right away. So definitely there is less load on the grid or less load on the JPS system. But as time progresses, persons start to turn on their TVs, they start to turn on their washing machine, turn on their phone, their laptop, their computers, blender, microwave. So all of those, once those start to come on the JPS grid or on the JPS system, eventually then the current actually get lower and lower. But as the current come back, there's a spike in terms of how much voltage, and that is simply because again everybody will not notice that the current is return, or all of the appliances not going to turn on automatically. So only like refrigerator and the electrical bulbs, that is if they were turned on, only like those appliances will switch on automatically once the current come back. So that is why there normally tend to be more electricity, just as JPS would have returned in terms of their electricity. So let's say for example there was a power outage, right, and then definitely the current would come back. Alright, so as for electricity and lightning, this notes. I'm gonna share the screen. Some persons should have the notes. I don't know how many persons don't have the notes, but I'm gonna send it in the WhatsApp group for those persons who don't have the notes on electricity and lightning as yet. Right, so I will send it in the WhatsApp group so those persons who don't have it can definitely get the notes and write it in their spare time. Alright, so electricity and lighting. Alright, so in terms of we looking at electricity, again, conductors and insulators. These two terms gonna come into play again. Just like how we're looking at method by which heat is transferred from one um, object to another. You would know, person should remember that conductors, as it relates to heat, mean that these are normally things in your environment that allow heat to transfer from one object to another. For example, metals. So anything that is metallic would be are considered to be good conductors of heat. That means that if you should have a piece of steel or a piece of metal, and at one end of the metal you actually apply some form of heat, then eventually the other end or the cold end of the metal will get hotter, or there will be an increase in temperature, simply because metal is a good conductor of heat, and it would basically allow the heat to move along its body. So in terms of electricity now, things that are considered to be good conductors in electricity mean that they actually allow electricity to pass through. And things that are called insulators as it relates to electricity are things, let's say, for example, rubber or plastic, and those mean that they don't allow electricity to actually pass through. Conductors are materials that allow electric current to pass through. So once you're defining conductor as it relates to electricity, it is any material or any things that will allow electrical current to pass through that particular material. Copper and aluminum are normally known as excellent conductors of electricity. So, for persons who manufacture electrical cables or electrical wire or electrical cord, they normally have a tendency to use a lot of copper mostly, and also aluminum. One of the main difference between copper and aluminum is that aluminum have a tendency to have a lot less weight than copper. So copper is much heavier than aluminum. So once you're being asked to give two materials that can transfer electrical current or electricity fast, or they are considered to be good conductors, that simply means that they have the capability to transfer or allow electrical current to pass through. These are normally used to make electric wires, and you're seeing the image there. So we have the multi strand inner connectors. So when you should cut open a piece of electrical cable, you will realize that you have a lot of smaller strip or a lot of smaller strand being wrapped or twined around each other. So that simply means that the more of them you have twining around each other, is the more electricity they will be able to carry. So that is why if you have one little piece of flimsy or a small piece of electrical cord or cable, or that you would purchase, you cannot plug heavy duty equipment like iron or washing machine or microwave in it, simply because those electrical appliances, they use a lot of electricity, and they will eventually burn the cable because of how much electricity they require. So you have to use a thicker one, and the thicker one definitely will have more strand in it, and the more strand in it is the more current they will be able to allow to go through, because electricity, is heat. That's why you'll realize that if you're using a heavy duty appliance and you plug it into a electric card, as time progresses it start to get warmer in terms of temperature, and it's simply because electricity is actually heat. So that's why if you should accidentally touch it with your wet hand or anything, it is just fire that is produced. All right, so conductors, so insulate, so we're looking at insulators now. So remember that once you're looking at electricity, these two terms, you must know the difference in terms of definitions, and you must also know things that are considered to be conductors and things that are considered to be insulators as it relates to electricity. So again, conductors are materials that allow electric current to pass through. Insulator. Now, when you purchase a electrical cable or electrical cord, part of the cable must actually be insulator, and part of it must be a conductor. So the middle section, which of course is the copper wires inside, those would be the conductors, because those are what carrying the electricity. Now the outer section now, that is made of rubber or plastic, those are insulator. That section is the insulator section, meaning that you can literally touch that plastic section, or you can touch that rubber section, and that is simple because the rubber, the plastic and wood, paper, or if it is made of glass, all those material are insulators, meaning that they don't allow electrical current to pass through. So that is why you can touch those section once they are made from plastic, rubber, wood, and of course glass. But there's a difference, or there's a very important note brief that person must be aware of, that if these materials, if they are wet, meaning that if the water is touching those and they are touching the copper at the same time and electricity is in the copper, then that can be dangerous, because water can conduct, especially if the water is pure water can conduct, can allow electricity to actually pass from the copper, which would be metal, to your body that would have been in contact with the water. So electricity cannot pass through because their electrons are not able to move around freely. So example, rubber, plastic, dry wood, paper, and definitely glass. Alright, so circuits, so electric circuits, and we'll be spending some time looking at how electric circuit is being formed. When we're gonna meet face to face, we'll actually go through different circuits, because we have different types of electric circuit. Of course, you have one that is called series, and we have a next one that is called parallel. So for the time being, now there are a lot of YouTube videos out there where persons can go online and look up these things. Just type in types of electric circuits in YouTube, and you will see a lot of video there showing you the different types of circuits, because definitely persons need to be aware of the different types of electric circuit. But circuit, as in electric circuit, that simply means that there's a circle in terms of the electricity moving in that cycle. So in order for an electric current to flow, there must be a complete path around which the electrons can travel. So there must be a complete path around. That's what I mean, that there is basically a circle that is created. This complete path is called an electric circuit. Now when you look at it, you can see a circle. So this is the battery, and you're seeing one end of the cable is attached to it there, and it go to the bulb socket, and this is the bulb. And then you're seeing at this other side of the bulb a cord is now coming from it, or a cable, and it actually goes to the switch. And then from this end of the switch, you actually have a cable that goes to a next section on the battery or the power source. So if you look at the movement of the cable now, there's actually a circle. So the only way this bulb can light up is by this circle completely closed, meaning that everything is attached to it. Now, the importance of a switch now, that is why you have a switch. So if there was no switch here and you just join the two, and the cable just continuous, then definitely once you attach the card to the battery, then the bulb would automatically light up. But there's a switch, meaning that on a switch there's a on and off labeling. Once you click it, then the once you click it to the on position, that means that two metals within the switch there actually touching each other. That's when the circuit is closed, and that's when the light bulb turn on. When you click the light bulb switch to the right position, or to the on position I should say, that simply means that clicking it to the on position mean that two metallic strips they are touching each other, and that is when the current or the circuit is actually closed. So current is now passing through the switch, so the light is turned on. When you click it to the off position, you actually disconnect those two metallic strip, and once it disconnect, then definitely there will be no electricity passing through. All right, let me transfer. I'm gonna send this notes in the WhatsApp group for those persons who have not written this part of the notes. Just get in the WhatsApp up so I can send it so that persons can have this set of notes to write.